This is chapter 7.2, similar polygons. Similar polygons, please notice the symbol for similar. It's like the topmost part of a congruent symbol. It's like a little wavy line. Similar polygons are figures that are not congruent. But with that said, there are two criteria, and one of those criteria does involve congruency. The first criteria is that the angles that match up, those are corresponding angles, are congruent. The second criteria is that the corresponding sides are proportional. This is where similar polygons are different from congruent figures, is that they're proportional, not congruent. We're going to go ahead and look at the checkpoint exercises on page 366. So I'd like you to take a minute to draw the figure on page 366, number 1. Okay, now that you've drawn the figure, we can look at all of the corresponding parts. The corresponding angles will be congruent, and you can see from the tick marks, the angle tick marks, that angle X is congruent to angle D, angle Y is congruent to angle E, and angle Z is congruent to angle F. Okay, so we've met the first criteria. Now we need to look at the second criteria, the corresponding sides. They need to be proportional. And they've asked us to look at the scale factor in the terms of B to A. So I'm going to look at the side ED, that's 9, to the side XY, which is 6. Simplify it and I get 3 over 2. Now all of this is a triangle, so it'll have 3 corresponding sides. All the sides have to have the same scale factor in order for them to be proportional. So now we're going to look at B to A again. This is figure B. Let's go ahead and write that in there. This is figure A. So we're looking at E to F, which is 18, Y to Z, which is 12. 18 over 12 simplifies to 3 over 2. So far, so good. We're proportional. Now we look at figure B again, because we're going B to A as our scale factor. So FD or DF is 12. ZX or XZ is 8. 12 over 8 simplifies to 3 over 2. All 3 of those corresponding sides are proportional. Their scale factor is 3 over 2. And so we can say that yes, triangle XYZ is similar to triangle DEF. Another thing we can do is make a statement of proportionality about those sides. Again, we're comparing B to A, so it's DE over XY. So DE on figure B to XY equals EF to Y over YZ equals FD over ZX or XZ. So again, that's a statement of proportionality. Okay, continuing chapter 7.2, similar polygons. Scale factor, we're going to write that definition in using deductive reasoning, an if-then statement. If 2 polygons are similar, so you have to know that they're similar, then the ratio of the lengths of the corresponding sides is the scale factor. So we used that in the previous example, and we saw that the scale factor was 3 to 2. So now we're in this example with the 2 rectangles. And again, I want you to draw those rectangles, write A and B, write the sides. I'm going to tell you that even though they don't tell you that these are rectangles, we kind of have to make that assumption because they've only given us PQ length and TU length, which is 12 and 10, so we have to assume that the opposite sides are the same length. And they've only given us RQ and VU lengths, which we would have to assume the widths on the opposite side would be the same. They also haven't told us that they are right angles, but again, we would make that assumption. I'm not a big fan of assumptions, but I think that's what they're having us do here. So again, write this down. You would have to assume congruent angles or right angles. And then the question is, determine whether the polygons are similar. If they are similar, write a similarity statement and find the scale factor of B to A. So we can't really look at the angles because I think they're having us assume that the angles are right and congruent, but we are looking at, are the corresponding sides proportional, because that's the second attribute. So if we go B over A, would be 10 over 12. If I look at B to A, 10 to 12, which simplifies to 5 over 6. Because remember, the scale factor they asked us to look at in terms of B, figure B, to figure A. Then we look at the second values that they've given us, which is figure B's width is 6, figure A's width is 9, 6 to 9. Both of those are divisible by 3, so you get 2 over 3. Those scale factors are different. Therefore, it is not proportional. Since it is not proportional, they are not similar. I cannot write a similarity statement. There is no scale factor because 5/6 is not equal to 2/3. Go ahead and have a look at page 367 in your text. There is a problem about perimeters of similar polygons. There's a pool with a patio around it, which are similar rectangles. That problem will really help you understand this theorem. So if you would take a look at that example 4 on page 367 prior to this theorem, I think that would be very, very helpful for you. All right, theorem 7.1. If two polygons are similar, that's the similarity symbol I put there, then the ratio of their perimeters equals the ratio of their corresponding sides. So this is an if-then statement, which is a form of deductive reasoning. So basically what this is saying is that if we know two polygons are similar, then the scale factor of the perimeter and the corresponding sides will be equal. So that's what I put. I put it just kind of in my own words here. If we know that two polygons are similar, then the scale factor for the perimeter and the corresponding sides will be equal. Now, we're going to go ahead and look at the checkpoint exercises. That theorem also is written on page 368. We're going to look at the checkpoint exercises right below on page 368, right below the theorem. And they're telling you in the diagram that triangle PQR is similar to STU. So they're giving you that information. So if you know they're similar, so that's where that theorem comes in. If you know the two polygons are similar, we're already being told that they are, then the ratio of their perimeters equals the ratio of their corresponding sides. Number 3 says x equals, okay, so we have triangle STU and triangle PQR. That's the scale factor they're looking at. If you look at number 4, it says find the ratio of the perimeter to triangle STU to triangle PQR. So we're going to look at STU first and compare it to PQR. Now, we know from the theorem that the ratio of the perimeters will equal the ratio of the corresponding sides. Since we already know they're similar, we don't have to do all of these, so it's going to be one or the other. So I'm going to look first at ST, which is 7, and then I'm going to look at the corresponding side, PQ, which is 14. Then I'm going to simplify it to 1 over 2. So that is the scale factor right there. That is the scale factor. I don't have to find any additional ones because I already know that they're similar, but I could have also chosen, just so you know, you could have chosen UT, and you could have chosen RQ or QRTU. It doesn't matter. So UT is 8, and RQ is 16. If you simplify it, it also is 1 over 2. You expected it to be 1 over 2, but you could have done either one of these. You didn't have to choose one versus the other. You only, however, need one because you already know these are similar figures. So we're looking now at the perimeter to determine if scale factor is also 1 over 2 for the perimeter. So we take the perimeter amounts. We've got 7 plus 8 plus 9 is triangle STU because we're comparing the perimeter of triangle STU to the perimeter of PQR. And we know that 7 plus 8 is 15 plus 9 is 24. And then we've got the other triangle, PQR, which is 14, 16, and we just found out the x value. So let's go ahead and write that x value. The x value will have to be determined proportionally. So we are going to take this 1 over 2, which is our scale factor. So we are going to take our scale factor, which is 1 over 2. This is so the scale factor of triangle STU to to triangle PQR, which we already know are similar, is 1 to 2. We already figured that out here. We want to know what the side PR is. That's X. But that's the PR is the big triangle, so the X is going to go down at the bottom across from the triangle PQR. And we know that its corresponding side on the little triangle is SU, and that's 9. That's the corresponding side SU, and its value is 9. We're going to use the cross product property, which means that you're going to multiply the means and the extremes, the things that are across from one another. So 1 times x equaling 2 times 9. 1 times x is x, 2 times 9 is 18. And so x, in fact, equals 18. So that's the answer to question 3. We needed that information to finish the perimeter problem on number 4. So we know that this x is 18, so we have 14 plus 16 plus 18. 14 and 16 are lovely because they come out to 30, plus 18 more is 48. We know that 24 and 48 are divisible by 24. 24 divided by 24 is 1. 48 divided by 24 is 2. So we can see that the scale factor for the corresponding sides is the same scale factor for the perimeter. So we've actually proven that with our figure. Okay, now we're going to go up and look at what the assignment is, and we're going to talk about which problems definitely need work. All right, your assignment is pages 369 to 370, 8, 12 through 20 even, and 22 through 27. And on 27, I'm going to strongly recommend that you draw pictures. So go ahead and take a second, pause the recording, write that down. You're going to show your work on the right-hand side of your paper. Now, number 8 does not require any work. It does have a fair number of answers, though, and I am going to strongly recommend that you draw the pictures that are given to you, because then the problems will make more sense when you're doing homework quizzes and quizzes. So number 8 tells you that triangle PQR is similar to triangle DEF. Knowing that, you need to list all pairs of congruent angles, so which angles are corresponding and congruent. Then you need to write the ratio of the corresponding sides in a statement of proportionality. And I'm going to draw your eyes down here. Here's a statement of proportionality on this left side at the bottom of the page. That's how you write it, a statement of proportionality. There's a fair number of steps to that one. Not hard, but a number of steps. All right, now we're going to 12 through 20 even. We're going to start with 12 through 16. On 12 through 16, it says determine whether the polygons are similar. If they are similar, write a similarity statement and find the scale factor of figure B to A. Make sure you do it in that order, figure B to A, just like we did in our notes. So on 8, you need work shown. On 8, no, excuse me, not on 8. On 12 through 16 even. And then if you turn the page now, you'll see that on 18 through 20 even, that it says the polygons are similar. The two polygons are similar. Find the values of x and y. You are also going to need to show work on those. Again, drawing the picture would be a very good idea for you. Okay, now we go down to 22 through 27. You've been given a diagram, and you're going to use that information. You've got a quadrilateral, and you know they're similar, and you're going to use that information to answer the questions. Some of those may require some work. 27 definitely requires work, so you may not need work on all of those, 22 through 26, but on some of them you may need a small amount of work, but 27 does, in fact, require work. Please show work. Refer to the recording if you have any difficulties.